All right, so today's areas and volumes of similar solids. So how can you compare them and how can you use them to find different things? So a reminder, similar solids are shapes that are the same shape but different sizes. So same shape but a different size. A note here, all dimensions have to be proportional. So these two rectangular prisms would be an example of similar solids because they're the same shape, they're both similar, or they're both rectangular prisms, but one is bigger than the other. So a scale factor then is how much bigger is something. It's the ratio of matching dimensions. So your example would be like the height of one divided by the height of the second shape. So if you did that over here, to find the scale factor, we could take the height here divided by the height here. So 3 over 6 would give you 1 over 2. So the scale factor is 1 over 2. So on these, to decide if something is similar, you have to get the same scale factor for everything. So here, 2 and 3 match up. So we get 2/3 for 1. 3 and 6 match up, which simplifies to 1/2. So right there, those are not the same. So this is not similar. Here we can do 6 and 5. Can't simplify that. And then 12 and 10, which simplifies to 6 over 5. So this one would be yes, those are similar. All right, so here's a table we're going to fill out. So scale factor we can do our two sides. We have 1 to 2, 2 over 4, and 3 over 6. Those all are going to simplify to 1 over 2. And then if you find the surface area and volumes of these, you can fill these in. I'm just going to write them down just to save time. So you should get a surface area of 22 for the small one and 88 for the large one, and then 6 for the volume for the small one and 48 for the volume of the large one. So here, if you're looking for a pattern, we're going to figure out what are we doing to each of these to get to the next one. So here you're multiplying by 2, and then by 4, and then by 8. And then a way to rewrite this would be times 2 squared, or times 2 cubed. So that brings us to these ratios. So if you start with your scale factor equaling A over B, then the surface area of one shape over the surface area of the second shape is that same scale factor but squared. And then the volume of one shape over the volume of the other shape would be the same scale factor but cubed. So you can use this to then figure out different things. So if we do an example, if your scale factor is 3/5 to begin with, then if you have the surface area of 1, surface area of the second, you're going to take your 3/5 and cube it, so you get 9/25 for the ratio of your surface areas, and you get 27 over 125 for the volume ratios. So how to use them? Here we know these two are similar because it tells us we want to figure out what is the scale factor of the smaller to the larger. So we know we have this as our basic volume ratio. The volume of the smaller one is 729, and the larger one is 1331. So then we just figure out what the A and B are. So here we want to undo the cubes. So to undo a cube, you want to raise everything to the power of 1/3. And you'll get an answer of 9 over 11. and that would be your scale factor. So to show you how to put that in a calculator, just because it's probably been a while, you would do parentheses 729 parentheses, do your caret value, and then 1/3, and that will then give you your answer. Okay, so if we keep going, the next one here is a similar one, so I'm going to skip this one. The only difference is you're going to square root things instead of squaring them because you have surface areas. All right, so here we have that the lateral area of two similar paint cans is this. The volume of the smaller can is this with the volume of the larger can. So you want to start by finding the scale factor. So our surface areas, we'll put the smaller one on top. So 425 on top and 1019 on bottom has to equal a squared over b squared. So you can square root these to get your a over b. So a over b will end up being 31.92 over 20.62. And then you can use this to figure out the volumes. So the volume of the small one is 1157. We want to find the volume of the other one. So you can use your scale factor, and we're going to cube these and then solve. So to solve this, you can cross multiply. So 1157 times 20.60 cubed is going to give you some huge number. It'll be, we'll just leave it written out. And that's going to be equal to 31.92 cubed volume squared. So divide both sides by the 31.92. And your volume should be, I did this backwards. You should flip these to the smaller on top. So these two numbers can be flipped. And you'll get 429.96 meters cubed. So again, flip these and put the 20.62 on top because it's the smaller number. I'm going to switch these two. And that will work. And this one is a similar idea, so I'm going to skip that one. But that's the idea. There's the assignment. There's also an 11.7 Math Excel if you want to do that.